Hello guys, this is Tushar Tomar and today we are going to discuss about benzoin condensation. Well, it is a nucleophilic addition reaction which involves two moles of aromatic aldehydes which react together in the presence of cyanide or thiamine to give alpha hydroxy ketones or benzoin as a product. Let's proceed further. So this is a basic introduction of this reaction. Here, enzymes catalyze organic reaction in biological systems. The high stereo, regio, and chemoselectivity of the reactions can be rationalized by the lock and key model. We can see it here. Enzyme can be classified into 6 classes depending on the type of reaction being catalyzed: hydrolysis, isomerases, ligases, lysases, oxidorreductases, and transferases. Often a coenzyme which is a small molecule, that is many vitamins, or a cofactor like metal ions, that is zinc, magnesium, iron, manganese, copper, selenium, are required as well for the enzyme to function properly. So now proceed further. Here we see the benzoin condensation using cyanide. The reaction can be carried out by using cyanide ions as catalyst, and the cyanide ion nucleophilically attacks the carbonyl group, leading to an unblock of the carbonyl group. Well, the reaction is much faster than coenzyme catalyzed reaction, but it requires better hood and a much more experienced experimenter. Now see its mechanism. So here it is mechanism. Here we can see that the Cn negative is attacking on the aromatic aldehyde, and we get, get it as the product. And after a proton shift we get this, and after this reaction we get this, and again after a proton shift we got this, and finally we get our product and Cn negative back. Now proceed further. So these are some problems which we faced with this reaction. Here is a possible formation of hydrogen cyanide if the pH value was not properly controlled during the reaction or work. And hydrogen cyanide has a low boiling point as well. It is highly toxic, as you see it here. And about 10 to 20% of humans cannot smell the compound due to a genetic trait. Now proceed further. Now we talk about benzoin condensation using thiamine. Thiamine consists of a pyrimidine ring, that is two nitrogen atoms in benzene ring, and a thiazole ring, nitrogen and sulfur atom in 5-carbon ring. The lab uses the hydrochloride, which is ionic and dissolve well in water but poorly in 95% ethanol. The highlighted proton is removed from the hydrochloride by the hydroxide ion. This hydrogen is much more acidic because of the adjacent nitrogen atom that bears a positive charge. Well, thiamine itself is pale yellow and not very stable in its free form. Now we will see its mechanism. So here is the mechanism, and step 1 is deprotonation of thiamine hydrochloride by hydroxide base to form thiamine, and we can see this here. And our step 2 is nucleophile attack of benzaldehyde by the deprotonated thiamine, resulting in benzoin, and we can see this here. And after this we are proceeding further. Now here we talk about the green chemistry aspects. The thymine based benzoin condensation is greener in many ways, as safety chemicals are used which reduces the dangers in case of accidents, dangerous waste prevention, higher energy efficiency. Well, the thymine based benzoin condensation is much safer than the cyanide based benzoin condensation. So thank you guys for watching my video, and I'll hope that you will find it helpful.